Perfect. Well, thank you, Stan, for that introduction, and I'm glad you all can be here to join us for this Mastering Jump webinar. If you're new to the Mastering Jump series, there's a number of these webinars you should definitely check out. They range from the very basic, which is basically this webinar, all the way up to some really nice advanced topics. So certainly check out the listing, and I'll show you that at the end under resources. But to give you a sense of today, the purpose of this webinar is mostly for people who have used Jump a little bit. So hopefully you've seen some of our other webinars or played with the software. If you haven't, don't worry, I'll still step through some of the basics. But the main purpose of this webinar is to give those of you who have used Jump a little bit a deeper insight into some of the basic platforms that we use for basic analysis and plotting. You know, so much of the analysis we do with data is not the most advanced analysis Jump can do. We're not always fitting neural networks or recursive partition models. You know, sometimes we just need to summarize our data. Sometimes we need a table with means and standard deviations. So some of these everyday tasks are made incredibly easy and incredibly powerfully using Jump. And so what I want to do is step through some of these more basic analysis and plotting procedures and give you some of the tips and tricks that help you get a lot more out of the software. So to give you an idea of today, I'm going to spend just a little bit of time talking about the anatomy of Jump. And I always like to do this, especially for new users, but even those of you who use Jump for a while, I think it helps to hear again just the basic layout of the software. Then we'll spend, for the first third, a bit talking about summarizing data. Again, a lot of what we do is just aggregating or summarizing what we've observed in whatever data we have collected. Next, I'll talk about visualizing data, and I'll spend a lot of time talking about Graph Builder. And in specific, I'm sure most of you have seen Graph Builder, but I want to talk about some of the functionality of Graph Builder that may not be so overt the first time you've used it. And then finally, we'll finish up with analyzing data. And this is a basic analysis and plotting section, so I'm going to be mostly talking about distribution and fit y by x, so univariate and bivariate analyses, but I'll certainly hint at some more advanced things you can do under fit model. And then finally, I'll finish with a point to some resources we have. You know, we never like you to feel like you're just on your own with Jump, so we've developed lots of resources that can help you, I think, learn the software and get the most out of your investment. So with that, let's start. And let me talk first about just the anatomy of the software. And to do this, I'm going to bring up some sample data. And I have a link. I'm using actually a Jump journal on the left-hand side here. We'll have some webinars about journaling, which I think you should check out if you ever need to do presentations. It's a very nice way to lay out your structure. But what I'm going to do is click on this link. But if you've never used Jump before, let me show you where you get these sample data. They're available under the Help menu. And you can go to the Sample Data section. And the sample data section has an organization of all the sample data sets. There's about 440 of them, and they're organized by type of analysis that the data are good for, and also industry type. So as you're learning the software, it's really nice to use these data. A lot of them include scripts, and I'll talk about that in a second, that let you work through the actual data sets. So for our purposes, if you're going to follow along now or later, there'll be a recording of this as well. You can click Open Sample Data Directory, and you could just start typing in restaurant tips, and that'll take you right to it. Now, since I already have it open, I'm just going to go back to my version of the file here. And what I want to first do is just very quickly talk about the organization of data in Jump and some of the ways we set up our properties of columns. There are some pretty important things about how Jump stores data that make it very efficient and very fast. But you have to know these things in advance to make sure Jump does what you expect it to do. All right, first, let's look at the data set. So we have a spreadsheet. Jump is not a spreadsheet software, even though we have the data organized in a spreadsheet. One thing that makes it different than typical spreadsheet software is we'll never have things like equals average. We won't have cell formulas. We don't put anything else in the data set except for the data we've collected. Now, you'll also notice that Jump has a dedicated column, or dedicated row, for the column names. So we never put names of columns in the data view itself or in the data set itself. Basically, everything in a column should be whatever we've observed or whatever data that column represents. Now, I want to talk a little bit about column properties. If you've used other software such as SPSS or even Minitab, you may be looking for how to get into the variable view, how you set up the characteristics of variables. Now, in Jump, it's pretty simple. You can take a column, you can right-click and go to Column Info, and this will bring up the column properties or the column information. And under here, you have some very important settings. Now, under column properties is a long list of attributes that you can set for this column. Things like value ordering, value labels, doing list and range checks, or missing value codes. Those are all available under the column properties. But what I want to focus your attention on here is something called data type and modeling type, because these will play a very important role in how Jump works as a piece of software. Now, data type represents really the way an observation or a cell is being stored. Now, there are two that we want to distinguish here: numeric data that's stored as double floating point, actually stored as a number, and then data that's stored as a character, so stored as a string. In programming, you can imagine this as a quoted entry. So numeric and character data, those are data types. But then there's a separate thing in JMP, which if you haven't used JMP before, this will probably be new as a setting you put in your software. And we call it modeling type. Modeling types count as continuous, ordinal, and nominal. And for those of you who haven't beefed up on modeling types, continuous data are interval and ratio scale observations that are on a true scale. So things like dollars, right? Dollars are on a true scale. The difference between $1 and $2 is the same amount as $100 and $101. That's a property of ratio and interval scales. We have other data types in JMP, ordinal and nominal. These are both categorical, and ordinal just means categories that are ordered. Think of t-shirt sizes, small, medium, and large, right? Those are ordered categories, but the difference between small and medium is not necessarily the same as medium and large. All right, so hang on to that in a second, because that's how we set modeling type. Modeling type is also shown in the data set under the columns list here. So these are all the columns that are in this data set, but you'll see next to each of them, there's a little icon. And next to the columns that are continuous, that are numeric, that have a real scale, you'll see there's a little blue triangle. And if I click on that blue triangle, you can see it says that that is a continuous column. So compare that to something like credit card, which is marked as a nominal column, right? Because that's a category in the environment. So why should we be telling the software that credit card's a category, whereas bill amount and tip amount are continuous? You know, what's the advantage of doing that? And to get into that, I want to spend just a second talking about the mind of JMP. And what I mean by the mind of JMP is what JMP thinks and why JMP thinks the way it does. And I always like to talk about this as a piece of software that's about process and not a procedure. And to kind of motivate this question, let me ask you this. You know, if you were setting up software, you were a human factors engineer or an interface designer, how would you organize thousands and thousands of analyses? How would you make the software easy to use, fast, and not feel overwhelming if you had thousands of different procedures and analyses to put in there? Well, you could have menus that are very, very hierarchical. So you could have an analyze menu, and then you can go to general linear model, and then you can go to univariate. You know, you can imagine these very nested menu systems. Now, JMP's answer to this question, how to organize analyses, is to say, organize them by what the question is they're answering. So let me ask you this. If you had a chi-square goodness of fit, that one sample chi-square test, and you had a t-test that was one sample, in most softwares, those would live in very different places because procedurally or analytically, they're very different. They address the question of, are there differences in a univariate space, but they do it in a very different way. One's parametric and one's not. For JMP, because those questions answer essentially the same type of thing, they'll live in the same place. JMP organizes things by what I call domain of inquiry, what question you're trying to answer. And also, JMP organizes or sets its menus up to be sensitive to modeling type. Because if you think about it, what you've measured determines or circumscribes the types of analyses that make sense. If I've measured something on a nominal scale, like a credit card, yes and no, I couldn't do a one sample t-test. There's no mean I could calculate there. So the software being aware of this is going to make it very easy and quick to produce analyses because JMP won't have to prompt you. It'll just know what type of analyses are useful. Now that's one piece of the mind of JMP. The other piece is that JMP is built in what I would call a deeply hierarchical way. That is, it's progressive. As you produce analysis, as you start analyzing, you're given new options. And this is sort of a fundamental feature of JMP. JMP was built to be an interactive window into data rather than a platform or a piece of software that simply lets you run analysis. I mean, you can run analysis from any software, but you can only experience your data using JMP. And so this is the progressive interface. And the seat of this interface, the way it works, is what we call these context-dependent outputs and menus. So let me put this all together and just give you an example. I think it'll make more sense for those of you who have never seen the software. So I'm going to go to the Analyze menu. This is where we find a lot of analysis. And I'm going to go to a platform called Distribution. Now, Distribution is a platform that's built to answer a particular type of question, questions that are about individual variables at a time. And what I'm going to do is I'm going to put tip amount and credit card. I'm going to actually take them both here and click them into Y columns. That's called casting them into a row. And when I click OK, what JMP will produce is output for these two columns. Now, notice that the output's a little bit different. For tip amount, we're given a histogram. We even have a box plot. We have quantiles and we have summary statistics. And yet, for the credit card column, even though I did the exact same thing, I'm given a frequency plot and the frequency table. Now, this is what JMP is doing, is contextualizing output. It's giving me output that makes sense given the modeling types of the variables I've specified, right? It wouldn't make sense to try to calculate a mean for credit cards. You can't do that. Now, this is one way that JMP is contextualizing. It's showing me output that only makes sense. But remember these red triangles, and we're going to see them a lot. There's actually 5 of them on the screen, one for credit card, one for tip amount, one for distribution, and then one for summary statistics. Sorry, that's 4. And these red triangles are the seat of the progressive interface. They are what lets you dig deeper. And so when you're learning jump, I say click every red triangle, because what these do are show you the more options that make sense. So think about this. We're in a univariate platform, a platform that answers questions about individual variables. That's what distribution is. We've put in a column like tip amount, which is numeric. It's marked as continuous. So this red triangle is showing me all the things that now make sense, given that this is where I am in my analysis or where I am in my discovery process. So this is where I would produce a normal quantile plot. And so this is the QQ to assess normality. This is also where I would go to fit a mean, if I wanted to test a mean and do a one sample hypothesis test. Or if I was doing a continuous fit, fitting different continuous distributions, and if I wanted to actually test them. Right, so that's what that red triangle does here for tip amount. But look down here under credit card. Remember, Jump is going to contextualize these menus. It'll only show me options that make sense. So under this menu, I'm not given options like a QQ plot. I'm not given the option to test a mean. I can test proportions or probabilities. I can get a mosaic plot. I can form confidence intervals around the proportions that I've observed. Right? Those all make sense given that this is where I am in the software. So this is what I call what we call the progressive interface. All right, so there's one drawback here, and I just want to bring attention to it, and that is, let's say you're looking for a very specific type of analysis. Let's say you're looking for a Mahalanobis distance, a type of covariance adjusted distance measure for outliers. Now, you could go digging through menus and Jump, but remember, it's deeply hierarchical. It's only showing you options that make sense given what you've set up. And so you may not know exactly where to look. Now, me having used Jump for going on, I guess, 8-9 years now, Jump's an old friend. I could probably guess where things are. But for you, I would say go to the help menu and write this one down if you've never seen it before. It's called the statistics index. And if you're looking for that very particular type of analysis, and I said the Mahalanobis distance, right? This is the covariance adjusted distance metric. You can go to that in the statistics index. You can click topic help, which will bring up the help file directly to where that part is in the software. And what's really neat is you can click launch, and this will bring up the platform in which that analysis lives. It happens to live in multivariate. I can give it a couple columns. For multivariate analysis, you need to give it numeric columns. And when I click OK, what Jump will do is pre-populate that output with the distance metric I specified, the Mahalanobis distance. And this is a pretty cool distance measure. I'll just pick one point to kind of show off why it's cool. So I picked this really extreme person, row 61, who has a distance of, up at 8.5. And if you look at that person in all the bivariate plots, they're just outside the typical area of where people are, right? Their points or their observation doesn't make a lot of sense in multivariate space. And so it's a great way to detect these multivariate outliers. And again, I got there by simply going to the statistics index under the help menu and going to Mahalanobis. So I encourage you to use that little index file. All right, so that's the progressive interface. And so the mind of Jump is, it's answering that question. How would you organize so many analyses? Well, they're organized hierarchically, and they're organized by context. And so as we go through the menus today, you'll see distribution. Those are all the questions that can be answered in a univariate way, in a way that's about a single variable. Fit y by x are all the relationship questions. When you have two variables, how does some x predict some y? And then fit model, which we'll talk about a little bit, is when you have multiple x's or multiple y's, and you're fitting some model that forms a relationship or tests a relationship between them. And so those are the big domains of sort of inquiry in the software. All right, so there's important features of Jump, and I'll just mention these briefly for those of you who've never seen them. Column and rows can take on states. So you can select rows. You can just right-click and exclude. This is important if you want to exclude data from analysis. Columns can do the same thing. You can exclude and hide columns. When you need to select certain parts of your data in order to do an analysis, and this is very common, and a way to do this is under the rows menu. And so under the rows menu, there's something called the data filter. And so the data filter is really neat. Let's say we just wanted to consider the tips for server A. So what I'm going to do is select server in my data filter. I'll click add, and I'll say highlight first server A. That's what select does. It selects the people in the data set who count as server A. And I could say only show and include the server A observations in any output I make. And notice by clicking show and include, it is excluded and hidden the rows that don't count as server A. So now if I were to go to analyze distribution, look at tip amount under my Y columns, Jump would only be showing me the tips for server A. a nice way to look at just a subset of my data set. Now, while we're there talking about these little subsets, let me hit cancel and clear out my data filter. I want to bring your attention to a by variable, something hopefully you've seen before, but this is another way of addressing that simple question. So let me go back to analyze. I'll show you what I mean. If I use tip amount as my Y column again, so I'm interested in tip amount, this by variable is available in every platform in JMP, and what it tells JMP, in JMP's mind, if you put a variable there, like server, I'll put into the by variable. In JMP's mind, that is telling JMP, do whatever I set up on the top, a distribution for tip amount, but split it up by server. Don't compare the servers, but just give me the same output split apart as if I did subsets of my data. So let me show you what that looks like. When I do it this way, you'll see I have distributions for server A, everything I set up before, distributions for server B, and distribution for server C. And so I can actually look at all of those separately, but in the same window. Now, imagine, and this is going to be a section I call broadcasting commands. Imagine you've done this. Let's say you work for a major company. You have 10,000 servers. So you have server A through, triple ZL or something. So you have 1,000 servers, and you've just put server as a by variable in your data set. So you have 1,000 different outputs in this one window. Suppose you wanted to go through and get a normal quantile plot for each of them. Now you could go to each red triangle, select a normal quantile plot, scroll down, go to the next one, select normal quantile plot, right? So you could do that 1,000 times, but that's a fairly time-consuming and laborious process. And the thing about JMP is, typically, if something takes a lot of time, we'll figure out a way to make it faster. And the way to make it faster is something called broadcasting a command. And what that means is, if I click on this red triangle, notice that all the options I have in this tip amount red triangle for server A are equivalent to what I have for server B and server C. They're the same context menu because we're in the same contextual place in the software. And so the way to broadcast my command, the way to tell JMP that I want to do a normal quantile plot for every one of these, is to hold down Control before I click the red triangle. Then I want to select the option, normal quantile plot, and then I'll let go of Control. And notice now it's populated that for every output in this distribution platform window. And what's neat about this is that control trick, it's command if you're on the Mac, but this control trick will broadcast any command that is applicable to something else in this window. And that's not limited to red triangle options. It's also, for instance, I'll hold down Control. Let me resize this window. It resizes all of them. Let me resize this guy here, make it really small. It resizes all of them. I'm still holding down Control. Let me click one of these gray triangles. Gray triangles in JMP show you less. And so I can minimize summary statistics and quantiles for everything. So notice that by holding Control, I'm able to do a lot of actions very quickly. And so again, imagine the use case where you have 10,000 servers or 100,000 servers. You'd be able to do the exact same analysis and process, and using that by variable, split it up and broadcast your commands. All right, so that's broadcasting commands. Now the final little important feature I want to talk about, and then we'll spend some time summarizing, analyzing, and visualizing, is column recoding. And I only mention this because so much of our work when we do analysis is just cleaning up the data we have. And I know that's always been, my background is I'm an experimental psychologist, so I work with data from people, and people give terrible data. And so much of my time is spent, cleaning up messes people make in their data sets. I'll give you an example. Let's say we were, again, working at a company, we had thousands of servers, and different organizations or different companies within our company like to use lowercase for some of their server letters. And so we had a data set like this, and I'm just changing some of these to be lowercase c's and uppercase c's. So I have these in my data set. Now imagine if I just got a distribution output for server, the first thing I would get is all the different frequencies for the different observations within the server column. But because some people used lowercase a's and some people used uppercase a's, JMP thinks those are different. All software will think they're different. Those are different characters. But to humans, they're not different. They're just different versions of the same character. So for the software, we would have to go through and clean this up. Now, a very quick way of doing that is selecting server in the data set, go to the columns menu, and select this option. It's called Recode. And what Recode will do is take existing observations, like these lowercase a's, b's, and c's, and what I can do is specify a new value for that old value. So for the lowercase a, I'll specify a capital A. For the lowercase b, I'll specify a capital B, and C, capital C. And now at this point, I can do a couple things. If I click OK, JMP will recode this column in place. And what in place means is it'll simply replace the values in the column it's already in. My preference, personally, I never do in place. I always do a new column or a new formula column. Now, the only difference here is that new column will simply write new values to a new column. Formula column won't just write new values, it'll actually write a formula that will then recode dynamically if I ever make other changes. So let me show you that one just because it's really neat. So server 2 is here. It's done the recoding. You see previously this was A and now it's capital A. I'm going to right click that column and you'll notice there's an option here for formula. Now remember I said that jump doesn't take formulas in cells. It doesn't. You don't put equals average or equals anything. Instead, columns themselves take on a formula. And so this column has a stored formula. It actually uses a match function, so a type of conditional logic. And so it's saying take the file or take the value that's in the server column, and if it's equal to lowercase a, make it now uppercase a. Same thing for B, same thing for C. This is a form of JSL. If you actually double click this, it'll reveal the actual jump code that's behind it. You never have to see that. You can build these functions just using the graphical interface. But it's nice to know that jump has a lot of power there. All right, so that was column recode using the formula. It's very, very powerful. All right, so that was just this basic section. And actually, before I go into summarizing data, let me pause. And if there are any questions about those basic bits, let me take them now. I don't know if Stan, if you've gotten any questions yet. All right, so let's move on to visualizing data because I want to show you the graphical equivalent of Tabulate. You know, Tabulate is a drag and drop. It's a drop zone oriented table creation. But let's say we wanted to instead create not tables, but graphs. So I'm going to keep that data set I had open. We've already worked through it, so I might as well show it to you in this one. And Graph Builder is available under the Graph menu. Now, the distinction between analyze and graph sometimes get murky. You can do analysis in both, and you could do graphing in both. But when we look under the graph menu, these are principally about creating graphics. That's your main focus. So let me pull up Graph Builder. And I'll be honest, when I first started using Jump, Graph Builder wasn't a part of it. But even when Graph Builder first became a part of Jump, I was still using, the built-in chart overlay plot. I was very comfortable using those platforms. But once I really started using Graph Builder, I saw the power of it. And the power of Graph Builder, like so much in Jump, is agility. Being able to imagine what you want to see and creating it right there on the spot. There's no going back. There's no, going back to a dialog window and setting things up differently. It's all there. It's all agile and it's all quick. So let me give you an example of this. We have this data set with a lot of different columns and a lot of different questions we can ask. So for instance, if we were really interested most in that SAT total, so let me actually take these two again. I'm going to do that inline transformation. I'm going to right click, go to combine, make a sum. I'm going to drag sum to the y-axis. And I want you to first observe what Jump has done. I have no x variable specified. So what we're looking at really is just the spread of data in one dimension. The fact that they're spread apart in this dimension in the x space is simply to make it visible. I'll show you what I mean. If I right click, I'll go to points and I'll turn off jittering. So jittering is what Jump was doing there to make these a little more visible for us. That's what it would look like. So by default, Jump would jitter points. Let me go back and turn that on. Now, if you look at the ribbon at the top, with only one variable specified, I actually do have different types of graphical or different graphical ways of displaying this, even though it's just one variable. For instance, I can get one big box plot or one big outlier box plot. I could get one big bar that serves no purpose at all for us. This is kind of a cool one. This is called the violin plot. Contour plots show density. They show density now in terms of their space in the X space, how much they're expanded out. And if I want to add multiple visuals, this is another thing you can do. You can click and drag from that menu bar a visual on top. So you can layer different visuals. I could actually layer a box plot too. So we're getting a little bit crazy here. But notice, even with one variable, we can do a lot of visuals. So let me start over though. Because what I want to do is take SAT verbal and math. Let me put it there. And let's instead actually designate an X variable and see what kind of visuals we can get. I'm going to use region. So let me take region. I'm going to drag it down to X. And when I drop it there, what Jump will do is now inside of each of the different regions show us the SAT total, right? And we could already see a lot of things happening. This is actually a great view. Looking at your raw points, people seem to like to always make them into box plots or bar charts or whatever. But look at your raw data. We get a lot of information here. There's splits in some of these regions. There's a big, wide split in the southern region, right? Some of the southern states here are doing very well and others not, right? So this gives us a lot of information that if we were just looking at it in a bar chart, it kind of robs it of a lot of its data. And just a personal thing, a bar chart is a complete waste of space. If you look at this, we're using a bar to represent a one-dimensional point, right? Just where the mean is. I would almost always recommend using box plots. Box plots show you not only the median, right? So the center of the data, just in terms of values, numbers, but it also shows you extremeness, right? It shows you density. It shows you if you have widespread or you have no spread, right? You also get the added benefit of looking for outliers. So box plots are really quite useful. But notice that I can toggle between these visuals. I can look for the one that makes the point I want to make the best. This is the important thing about graphing always, right? The best graphic is the one that tells your story. It's not that it's the most prettiest. It's not that it's the most concise. It's the one that tells the story you need people to extract from your data. And so when you make a visual, always have that in mind. What is the message you're trying to convey? So on that point, let's think about other things we can do with this. You know, if I was wanting to show year-to-year change within a region, I want you to see how we might be able to make this graphic work for our purposes. So let me grab the year variable, and I want to show you several different things we can do with it. Now, the first thing I'm going to do is drag it over to this group for X. I'm not going to drop it here, but I'm just going to hover it here because I want you to see what jump does. When I hover over a group for X, it's showing me each of the different sort of setups that we had before, this region by SAT total. It's grouping that inside of each year. So we have 1992, all the region changes, 1994, all the region changes, etc. Now, if my purpose was to show year-to-year changes within a region, that's not doing very well for me, is it? Because year-to-year changes, I would have to look at Midwest here, look at Midwest here, look at Midwest here. That puts them in the wrong place. So let me show you another neat trick. You know, having just set this up, I'm going to right-click year, and I'm going to go to swap, and I'm going to say, I want you to swap that with region. Let me flip those two around. Ah, now I can see region-to-region change, right? Or sorry, year-to-year change within a region. Right, this makes a lot more sense. Plains going up, the South going up. You know, we can see spread changes too. Some states are getting more variable, or regions are getting more variable over time. Right, so knowing what purpose your visual is serving is obviously very important. So while I'm at it, let me grab region again. I'm going to drag it to some different places. I'm going to drag it over to wrap. So look at what wrap does. Wrap, instead of breaking it up strictly across the X space, is now wrapping it across the dimension. If I go group for Y, right, that's kind of doing what group for X was doing, except now it's splitting it up across the Y-axis. And one final one is overlay. I want you to see what overlay does. Overlay would give each of the different regions their own color, and now is putting them within each year. And so actually this is sort of the inverse of what we had the problem with the first graphic, which is our region changes over time are hard to see because we've split region up over a big space. So again, I might want to right-click year and swap it with region. So now we have overlay as year and region actually back as our x-axis. Right, so a lot of graphing flexibility there. And that was with a nominal x. Remember, JMP is paying attention to what our modeling types are, so it can help us choose visuals that make sense. Let me start over and let's consider something else. Let's predict SAT total on the basis of, let's say, expenditure. Now, for the moment, let's ignore our degrees of freedom problem, and let's just look at the plot it comes up with. So if we're looking at this, we have our bivariate plot, so it's just a scatter plot, and the first visual that JMP chooses, let me remind you later about that, the first visual JMP chooses is what's called a smoother. A smoother is a type of, you can think of it like a moving average. It's a line that has variable stiffness, and the controller here for lambda effectively changes the stiffness of this line. So if I go all the way to the right, this is equivalent numerically to a linear regression of SAT total onto expenditure. If I go all the way to the left, this is essentially fitting lines to each of the different means as quick as possible. So it's recalculating pretty often. Now the value of the smoother is to look for nonlinearity. So for instance, if I was just fitting a linear regression line, I might miss the fact that there is some change locally here. Maybe it went down or for some reason. Not always sensible, but something you want to look for. Now if we look along the top, the ribbon here, we can see other options we have. If we want a proper linear regression line, we can click that on here. It'll automatically put on the working Hotelling confidence band. We can change the degree. So if we wanted it to be quartic or if we wanted it to be cubic, we can turn on the equation, root mean squared error. A lot of flexibility with that. One that I really like, I just like the density ellipse. This is a nice way of seeing the center density of the data. Let me do one final thing here, because this is a neat thing about JMP that took me a while to find actually. Under map shape, we may have times where we have in our data set something that identifies states or identifies regions. And so we have state in our data set. And so I want to show you something cool here. Let me take state drop it down on map shape, we get the map of the United States. Let me take that SAT total I made, and I'm going to drop that right in the center. Notice what I get now is I get a geographical display. Maybe my point is not to show numerically how things are changing because of expenditure or because of population. Maybe I'm making a geographic argument, and showing scores this way is going to be more useful for me. And so what JMP has done is it's picked a color scheme. You can always double click this and change your color scheme. Personally, if I'm making a point about things increasing or decreasing, I typically opt for a sequential. Sequential has the nice property of darker means something always in a specific way. So darker means better here. And if I had other variables I wanted to sort of represent this relationship over, for instance, time. So I have a year in my data set here. I could use this in some different places. I'll show you my favorite. I like to use year as a wrap. And so here we can actually look at changes from 92 all the way to 2004 in the SAT total. And so a real easy way to sort of visualize this. So a lot of power in Graph Builder. I think Graph Builder is one of these ones where you can play with your data for hours and hours and come up with these different ways of really representing them. Once you're done, just click Done, and now you're ready to save this Graph Builder as, you can just save as. You can actually, if you want to, go to, let me get my menu back here, this little big fat plus sign, and you can actually select this whole thing, and this could just be copied out as a high resolution graphic. In Windows, you can also save selection as, and just save this out as an EPS. And so a real easy way to show changes over time. All right, so that's Graph Builder. I want to pause here. I can show bubble plot quickly, but I want to pause actually and take any questions about Graph Builder, and then we can look at some more graphing and some analysis. Sure. Well, let me show you one more thing with visualizing data, and then I'll take a question after that. Because we're already in the data set that's good for it. And this is called a bubble plot. So I like to show bubble plots, especially when you have lots of dimensions of data to show. And this is a perfect example. We have a lot of dimensions here that could account for changes in SAT scores. And so bubble plots are a great way to show this. Let me jump right to the end to show you what a bubble plot looks like, and then I'll show you actually how we set it up. So let me go to Run Script. And here's a bubble plot. And what we have are bubbles for each region of the country. So mountain, Midwest, different regions. And you'll notice here we have a little controller for year. And right now it says 1992. And if I drag that year, we can see how these different regions are changing in their locations in this plot. And the location here is just SAT math plotted against SAT verbal. So going up and to the right means you're increasing in your average score on both. And if I click play, JMP will actually just play this for me. Now what a bubble plot is doing is it's showing us lots of dimensions of data. It's not only showing us the location of each state at a particular time, it's showing us changes over time. And the colors of these bubbles, and in fact the sizes of these bubbles, is also under the control of this platform. Let me go into the drop down here and just show you the roles. So if I show roles, the time variable is year, our ID, and I'll talk about that in a second, is region, and the sizes of these bubbles are the percent of people in a state taking the exam. And so it's kind of neat that we can use this bubble plot to show a lot of changes over time. Now there's one additional thing this one can do. Because I have two different IDs, and I'll show you how I do that, I can select a bubble, here's the South, and I'm going to click Split, and it shows me the constituent states of the South. And remember the South had that big split in them, so this is again showing us that big split. I could even hit Combine and bring them back together to be the South. So anytime you have data that's representing something over time, this is really neat to show. And so let me show you how you set this up. It's under the graph menu, and it's called Bubble Plot. And Bubble Plot allows you to add on different things. So Y and X we can specify here as verbal and math. Now ID, this is what represents the units in your data set. So I can put region in, and then I can put whatever is nested under that, whatever is the subcategory of region. And states are really nested inside of regions. They only occupy in one region. Now time can be anything. I'm going to use year here, but it can be any variable you want to show changes over. And then finally, we can choose things for sizes. I can use proportion taking. We can have things for color. We can use expenditure. And remember that by variable, if you really wanted to have separate bubble plots across the levels of another variable, you can split it up there. But this will produce that bubble plot for us. And the only other change we had is under the drop down, we had selectable, we had trail bubbles on, I believe, to show the selected ones. So bubble plots are very neat. And if you have data that actually is geographic, so you can actually show latitude and longitudes, if you right click, there's something called background map here. And so if you right click, you can actually put on a little background map. You can do a simple Earth. We don't have latitude and longitude in these data, so it's not going to work here. But you can turn on simple Earth, street map service, so you can actually get down to street level detail for this. US states you can also turn on, or different regions. So if you have data that is showing latitude and longitude changes over time, you can actually show this sort of like real-time changes on a map. So a pretty neat way to show data. All right, so that's the bubble plot. So we're getting very close to the end. I think we're just hitting noon now. So before I take any final questions, I'm happy to stick around. I do want to point you to some learning resources so you don't feel like this is your last chance to learn. Jump.com/learn takes you to what's called the Learning Library. And I just want to make a point of this. We develop these resources typically for academic users, but we think anybody learning Jump can get benefit from certainly some of these resources. So for instance, if you're doing some specific data mining technique, classification trees, you can go to that section here. You can look at two different types of resources. One is a one-page guide. And so this is a PDF you can print. It uses sample data, shows you where the sample data is, and steps you through that process. And if you like, you can also click Watch Demo, and this will take you over to YouTube. I try to make these videos maybe 3 to 5 minutes, and so they're not too long. You can certainly pick up a brand new technique in Jump pretty quickly. And yeah, we hope these are useful as you're getting more used to the software, and certainly so you can get the most value out of your investment. All right, so I'll stop there, and certainly stick around for any additional questions anybody has. But for those of you who have to leave, thank you so much for coming, and certainly check out the rest of the Mastering Jump series.